All right, so polynomial division. You can go crazy with division. We're not going crazy with division. The only thing that matters to us is the remainder. If the remainder is 0, you just found the x-intercept. And you found, well, we're going to say factors. I'm going to save that stuff for later. And I did write factors plural. You'll see why in a moment. If the remainder is not 0, it's just a y coordinate. And I'm abbreviating coordinate to look like that. Okay. There's two types of division. There's long division, which is long. And then there's synthetic division, which is short. Now look, I'm going to zoom out for a moment. I am only doing one example with long division, and this is going to take me right down to this line of my paper. So if you don't have this much room, maybe you want to go to a new sheet, maybe you're going to make yourself write small, but it is going to take up quite a bit of work, quite a bit of space. Let me zoom back in. So if you could please write that down. As you write that down, comprehend everything about the numerator that you can. What's the degree? Are all the degrees there? What does the degree mean in behavior? What's the leading coefficient? Everything that you can absorb from the numerator, try to do it. And then also, I'm using a red pen because I'm doing a shortcut because I hate long division. So if you have a red pen or a different color, I'd use it. If not, it's never a deal breaker. But if you do have it, the shortcut stands out. All right. So I'm so glad that you wrote that down. Now we're going to transform it into long division with a long division box. So I'm going to draw my long division box. And it is so long, it's so ridiculous, it has to be really long. Now, remember, what is on the bottom goes on the outside. What is on the top goes on the inside. So, as I'm writing, I'm not even writing this yet until I know all the degrees are represented. This is to the 6th. Do I have a 5th? Yes. 4th? Yes. 3rd? Yep. 2nd? Yep. 1st? Yep. Okay, now I'm going to copy that exactly how it is right here. All right. Ooh, I'm zoomed in too much. I'm sorry. There we go. All right, so I wrote it from fraction form in long division form. So when we divide, it's all about making that x look like that x. That x doesn't look like that x. So I'm going to take this and I'm going to multiply it by x to the 5th, because x times x to the 5th is x to the 6th. But when you do this long division, line up your degrees. So I'm going to multiply this by x to the 5th. I'm going to put x to the 5th right here, right above it. So x to the 5th times x is exactly what I wanted, x to the 6th. X to the 5th times 2 is just going to be a positive 2x to the 5th. And then, this is why I'm asking to have the right pen. How many times does 4 go into 25? Yes. So I put a 6 here. And that times that, that's what we just did. What would I do next? Yeah. I will in a minute to save that. What do I do? What kind of sign is that 24 right now? Positive. What happens when I put a minus? Is that still a positive 24? No, the sign changed. So that's why I asked you to have a red pen, because we have to change all the signs. And if you just have a red pen, you just do this. method. All right, so let's subtract. So the front numbers cancel out every time. If those front numbers don't cancel out, we made a big mistake. That's a zero pair. A negative 2x to the fifth and a negative 2x to the fifth is a negative 4x to the fifth. And then, Matt's already said it. So 25 minus 24, that's a 1. But what if it wasn't 200 or 25? What if it was 251? You bring down the next term. Let's bring down the next term. Bring down that x to the fourth with the plus sign. So you need to write the sign in front of it also. Okay, I want to make that x look like negative 4x to the fifth. So I'm going to multiply by negative 4x to the 4. I'm going to multiply negative 4x to the fourth times x, negative 4x to the fifth. Negative 4x to the fourth times a positive 2 is a negative 8x to the fourth. Red pen time. Got my little zero pair right here. X to the fourth and 8x to the fourth is 9x to the fourth. Bring down the next term. I need an x to turn into 9x to the fourth. I'm going to multiply it by a positive 9x to the third. 9x to the third times x is 9x to the fourth. Okay. 9x to the third times 2 is a positive 18x to the third. Red pen time. Change your signs. Combine straight down. My first terms cancel out. Negative x to the third and negative 18x to the third is negative 19x to the third. Bring down your next term. So write plus 3x squared next to that. All right, I want that x to look like that. I am going to multiply it by a negative 19x squared. Negative 19x squared times x is negative 19x to the third. Negative 19x squared times a positive 2 is a negative 38x squared. Red pen time. Change both these guys to positives. All right, look. A positive 3x squared and a positive 38x squared is a positive 41x squared. Bring down the next term. I want x to look like 41x squared. We're going to multiply it by a positive 41x. 41x times x is 41x squared. 41 times 2, do that in your head. Think about doubling 41. 41 doubled is going to be a positive 82x. Red pen time, change the sign. All right, a negative x and a negative 82x is a negative 83x. Bring down our term. Oh, this is the last one. We're almost done. Now look. All of that work leads us to this. This is the only thing that matters for us in pre-cal. What happens after this last step. All right, here we go. So I need an x to look like negative 83x multiplied by negative 83. Negative 83 times x is negative 83x. Negative 83 times a positive 2. Think about doubling 83 in your head. A positive times a negative is a negative. This is going to be a negative 166. Red pen time. Change your signs. So a positive 24 and a positive 166 is 190. The remainder is 190. I'm not going to be happy about that, especially next week. You'll see why. Not a complete wash, though, because 190 is a y coordinate. And then let's talk about that. So I'm going to write something over here. It's going to seem totally unrelated, but it's not. Y'all remember that's a parabola. It's been transformed. This graph has been shifted 7 places up and 4 places to the what? Right or left? Right. It's always opposite. So the x coordinate on the graph is opposite. So the only thing that you found after all that work, you just found a point on the point. There's a point on that polynomial. It is at -2, positive 190. It is always opposite. Look, I graphed it for you. Let me show you. Where am I? Right here. Home. So I graphed it, but it's not showing up. Wait, what was that ordered pair? -2 what? Oh, I'm only on the 6 on the y-axis. Let me zoom out. Here it is. Here's where it starts. Remember that polynomial was positive. It had this same end behavior because the degree was what? What was the degree of the numerator? 6? Yeah, it's not on. So let's look at this, guys. If that's the lowest it's ever going to get, we were never going to have a chance of getting a 0 right here because 0 means it's the next intercept. We could plug in any number we want and we will never get a 0 because it's never going to cross the x-axis. But let me show you where that point is. So here's 180. Let me trace that. 188, 189, 190. There it is. There's -2, positive 190, which was what we found. Okay, so we have talked officially about long division, and I'm done with long division forever in this class. Let's go ahead and talk about synthetic division. Way easier. Part 2, synthetic division. Here's what we're going to do the rest of the time. Here's what we're going to do next week. Synthetic division. All right, so again, as you write this down, absorb every piece of info that you can think of. Leading coefficient, degree, and behavior. Are all of your exponents represented? The highest degree is 4. Do you have a 3? Do you have a 2? Do you have a 1? Okay, this does not take up much room. I'd say if you have 3 or 4 lines or 5 or 6 lines, you should be fine. All right, here we go. We are going to do fake division. Fake division for me is the upside down division box. So please draw an upside down division box. And we're going to put what the real x coordinate is from this factor. So that says x minus 3. So the real x coordinate is a positive 3. That's going to go out here. And then all I'm going to do, guys, is I'm just going to write the coefficients of this on the top row as long as all of my degrees are represented. So on this top row, I'm going to write positive 2, -7, -38, positive 103, positive 160. But I am going to space them out. See how long I drew that? I'm going to space it out like this. All right, I'm still having my red pen because there's still important stuff here. So remember, for synthetic division, you always just bring down the first number. You never mess with the first number. And then you multiply, and it's a cycle. I'm going to do 3 times 2, which is 6. I'm going to put 6 right there, combine straight down, do the same thing over and over and over. So 3 times 2 is 6. I'm going to put a 6 right here. When I combine straight down, it's a -1. 3 times -1 is a -3. -38 and -3 is a -41. 3 times -41, you should be able to handle that in pre-cal. Think about 3 times 40. Think about 3 times 1. So 3 times -41 is what? Yes, it is. Great job. So positive 103 and negative 123. What's 3 times -20? It is. Look. Do you have a remainder? No. I'm telling you, you're going to be so happy when that's 0 next week. You just blew up so much information. Y'all look. So back over here, instead of me dividing by 251, let's pretend it was a 6. 4 times what makes 16? 4. And when I subtract, I get 0. Yes? So is 4 a factor of 256? Is 64 a factor of 256? Every single time you get 0, you found 2 factors. So, look at all this stuff. Here's the first, what we found. Look at all this stuff we found. We found 3 things. First of all, we found an x-intercept. We know the x-intercept is 3, 0. We found one of them. What else did we find? We found a factor. So go back to the original. X minus 3 is a factor. And so is the answer. So look, this 2, -1, -41, -20, those are coefficients for the factor of the polynomial. But the polynomial, this answer gets knocked off a degree. This was a degree of 4. This is going to kick off a degree of 3. This is 2x to the third minus x squared minus 41x minus 20. Like this. 2x to the third minus x squared minus 41x minus 20 is a factor. That is the business.